Hi, good evening to everybody. I'm SASHIKUMAR MURUGAYAN from Mechatronic System Design student. So today my title going to be shared on the IoT based chemical preparation and monitoring system for semiconductor industry. So my content will be covered on the project title, introduction, problem statement, research objective, result and discussion, research gap and conclusion. So my project title, as I mentioned, IoT-based chemical preparation and monitoring system for semiconductor industry for automated preparation process, ensure accuracy and provide real-time monitoring and control to prevent error. So let's move to introduction. Important for precise chemical preparation for semiconductor industry. Challenges in traditional chemical preparation, human error, inconsistent and insufficient. An objective is to implement an IoT-based system with a real-time monitoring and with automation. So for the problem statement, let me touch on the detail. Manual chemical preparation is currently inaccurate and insufficiency. Lack of real-time monitoring result in deviation from required chemical composition, and current automated systems are limited in remote monitoring and intelligent decision making, and need for an integrated IoT solution for smart chemical preparation and anomaly detection. So for the research objective, so develop an IoT-based automated chemical preparation system, implemented real-time monitoring using water temperature, ambient humidity and pH sensor, and utilizing machine learning KNN classification for anomaly detection, and optimize chemical resource utilization and safe and compliance to the user. So here is the system connect to the Blink and to the IoT system with the handphone monitoring, and beside there it's also a real time to measure the data as an output. So result and discussion, it able to discrete analysis with a comparison of normal and abnormal condition, and we come out with the block spot histogram analysis to identify the variation in the water temperature, humidity and pH, and we use a KNN classification result around 96.67 accuracy in detecting abnormal condition, and with the confusion matrix interpretation, high sensitivity and specifically ensure effective anomaly detection. And the research gap here, I would like to emphasize more. So current solution lack of real-time decision making and remote accessibility, and absence of machine learning integration for automated classification, and limited application of IoT-based control mechanism in industry chemical process, and need for a comprehensive smart system with integrated sensors, microcontroller and cloud-based monitoring. So as a conclusion from this project, the smart chemical preparation and monitoring system successful integrate IoT, real-time monitoring and machine learning, ensure precise chemical mixing to reduce human interference and improve process efficiency, and highly accuracy in anomaly detection and enable proactive decision making. Future enhancement, AI driven predictive maintenance and improve sensor integration. So thank you guys and stay tuned. After this, I'm going to share on my project physical design, and I will explain more detail on the functionality test and how we perform the KNN coding to predict the classification. Thank you guys, stay tuned. Good evening to all. Today I'm going to share on my project title, Smart Chemical Monitoring and Preparation. So come, let's join together on my explanation. Okay, for my chemical smart monitoring and preparation, I'm using an Arduino Mega and a Moto Equator in the tank 1, and then a pH sensor, temperature sensor and an ambient sensor. and supply for the circuit is 12 volt, and then step down power supply 5 volt for the relay and the LCD, and for the sensors, 3 sensors is run connected by the Arduino Mega. Okay, on the LCD here we have a pH sensor reading as an output, water temperature, humidity, and ambient temperature. Okay, here I'm using a Arduino coding. I derive all the coding here for the 3 sensors and actuators. Okay, 3 sensors and actuators, and here is my blink wet base for the pH sensor, water temperature sensor, and humidity temperature, and humidity RH value. Okay, tank 1 is our high concentration chemical, and tank 2 is our process chemical. Now you can see empty. Later the actuator will pump the water from tank A to tank B, and tank 3 is the standby tank, has our abnormal condition verification. Okay, here you can see very clearly the water from tank 1 have been transferred to tank 2 when the pH is 3.1. When the pH, see on the screen, is 3.1, means is lower than the neutral condition. Okay, now for the tank 2 is our process tank. We use this chemical for our process, and the pH here is 7.1 according to the LCD screen. Okay, 7.1, and our wet also showing 7.1. However, the water temperature is 25. Okay, so ambient temperature is 26 and humidity is 60. So here I'm going to show my functionality for my temperature. So here I insert into the cold water. Here start to decrease, is going down, very cold. So my sensor functionality is accurate, and I put in the hot water. The temperature, water temperature is raising up, so it's showing that my sensor is working. Now on the screen for the humidity sensor is 60, and I'm going to show the functionality for my humidity. Sensitivity, and there's no changes. Okay, but it's okay. Now I'm going to show that my hold on. Sorry, just now the temperature is about 60 and there is some propagation delay, and now only the sensor sensitivity is getting down to 58. So it shows that all my sensors functionality are accurate. Okay guys, now I'm going to show that I'm linked to my handphone blink to show that it more to IoT. So login. So it's connected, and chemical preparation. So see guys, on my phone screen, temperature 7.1, water temperature 25.4, and water humidity 27, ambient temperature, and humidity 58. Humidity on the screen is 58, so it's synchronized. Okay, all my sensing data for every 2 seconds, okay, it have been lively generated in this template. So I'm going to maximize to show. Okay, here is the pH, water temperature, humidity temperature, and humidity RH. So this is the real time. So you can see the data has been captured in real time, and pH is 7. Okay, it's real time captured. One, two, three. Okay, here I'm going to stop this data, and then here save. It will be saved to my PC. So here I save this data has a live data, has a name of cam data. And guys, this data later I will be export to my another PC to run the KNN classification under the Google Colab. Okay, here I already transfer the data as a cam data into this PC. Okay, so now I'm going to show how I'm going to export into here. Okay, already export. So we run. So here are my data and humidity, water pH, and water temperature. So here is my matplotlib plot box data have been generated. And here is my KNN pickle files. So here guys, you can see for my K1 99.38, K2 99.38, and K300, K400, K500. So here I take K5 as my 100% accuracy. Okay, click record. Okay, now I'm going to upload this KNN file for my KNN predict chemical later. Okay, here is my KNN pickle file, and then this is my cam data for testing 1 point humidity, temperature, and water pH. For 1 point sensing to check the KNN classification. Okay, let's go to KNN predict at the Google Colab. Okay, here is the KNN predict chemical. Okay, let's run. Okay, now we're going to upload the cam data. And together with the KNN pickle file 5. Then we import pandas. So here water temperature 26.62, humidity 72, water pH 4.8. and is showing normal. So guys, my KNN result showing normal, and I managed to complete. My KNN classification is showing normal for this 1 point of testing data. Okay, thank you.